everyone, welcome to my channel. So this is the second room from AI security learning path, which is AI models and data grouped in AI fundamentals. So let's join this room. Okay, so learning objective of this room will be understanding uh, understanding where AI training data comes from and what are the security risks which are introduced by poor data provenance. Recognize how PI and sensitive credentials can become permanently embedded in models. So if you click on PI, you can see what actually PI data is, which is personally be identified information. Okay, and there is one reference link as well. So how key model building decisions like overfitting, quantization, and federated learning are introduced. Understand the inheritance problem and recognize why trained models are opaque black boxes and what model cards do and fail to do to address this. And the prerequisite will be to complete the AIML security threats room, which you can watch by clicking on this eye icon. Let's start quickly. Training data. So in the previous room, which is AI ML security threat, we walked through the machine learning life cycle and established that before a model can be trained, data must be collected and then cleaned. Okay, but let's slow down a tad and ask the question that life cycle diagram doesn't answer. Collected from where? From where that data should be cleaned, and who will be cleaning that data, and how it will be cleaned. Okay, so let's see, where does all the data come from? There are multiple sources. First one is web scraping. It is like automated crawling of public internet content, which is news, forums, blogs, social media, etc. Trust profile: how much data can be trusted? Low, because there is no a single dedicated curator, no version control, and no content changes after collection. Okay, once it is there, it is there. It is just given by the public. Okay, so like no fact check or validation is done at get extent. Okay, then we have licensed data sets which are purchased or agreed with platforms like OpenAI plus Reddit, Meta's own social posts. So trust, how much this data can be trusted? Medium. Terms of an unclear, original users rarely consented to AI training use. Okay. Synthetic data, which is AI generated content used to train further AI systems. So its trust profile is variable, which it is growing fast. Approx 12% of fine tuning data sets now contain LLM generated content. Then internal corporation, companies knowledge bases, support transcripts, clinical notes, which has higher trust profile because on this data organization has direct control. They regularly validate and fact check all the data. Okay, and also they will be directly liable if data is mishandled. So the most widely used training data set is Common Crawl, a free publicly available archive of web crawl data that underpins essential every major model family. So DeepSeek was pre-trained on in LLM. MA4 was trained on this. GPT-3 is one of the few models whose breakdown is publicly documented, which 60% of the token came from a filtered version of Common Crawl. Now, the problem of provenance. So data provenance is the ability to answer three questions about any piece: where did it come from, and when it was it collected, and has it modified been since? Okay. So the honest answer is obviously we fully don't know. Most are essentially trained on data sets, huge composites assembled from hundreds and thousands of upstream sources. Okay. So the data provenance initiative audited over 1800 data sets and found that more than 70% of license on popular hosting platform were listed as unspecified. 66% were miscategorized. Okay, then we have PIA information in the pipeline, like all the confidential information about the users, and it is very critical in the compliance domain as well. So the EU's GDPR explicitly requires data minimization, collect only what is necessary. Okay, let's see. The security implication is measurable and concrete. Truffle security, Truffle log, we know that scanned the December 2024 Common Crawl archive around 400 TB of data and found nearly 12,000 live verified API keys and passwords. So you can see what will be the impact of that. What is a model engineer? A model behavior is a direct product of what it was trained on. It is very simple. If that data was scrapped without audit, contaminated with PII information, or manipulated upstream, those will be visible in the output as well, and the performance of the model as well. Okay, so the data supply chain is as real and as exploitable as software supply chain. Let's answer some questions. What term describe the ability to answer where data came from and where it was collected and whether it has been modified? We just saw that it was data provenance. See, spelling is correct. Yeah. What is the name of the most widely used public corpus? We saw that common crawl. What is the AI equivalent of a software bill of materials used to document data set sources, licenses, and filtering decisions? Let's see. Okay, it's ML bomb as written here. Oops. Let's say building the model. Key concepts. Okay, so epochs and overfitting. An epoch is one complete pass of the training algorithm through the entire data set. Okay, so in practice, models are trained over many epochs. The algorithm repeatedly sees the same data, adjusts its parameters, and each time until full coverage is done, and it can assume get as much as accurate predictions. The main catch is that more epochs don't always mean a better model. Train for too long and the model stops learning with general patterns and starts memorizing training data specifically. So it will not like absorb new data. It will not train new patterns. It will just start memorizing the training data specifically, which is a problem called overfitting. So overfit model perform well on its training data but poorly on the other data. Okay, so it's like just a bookish knowledge. You just have read one book over and over again, so you are very well trained on that book. If question comes out of that, you are like just blank. To catch overfitting early, a portion of training data is held back and never used for training. This is the validation set. So at regular interval during training, the model is tested on unseen data to check whether its performance is actually generalizing or just improving on the training example it's seen before. Okay, so it's like a quality gate in the ML lifecycle validation. So post training optimization, pruning, and quantization. So once model is trained, it often goes through compression steps before deployment. Okay, so the most common methods are pruning and quantization. So what is pruning? So it removes parameters that contributes little to prediction, shrinking model size. Okay, so it changes model behavior post training, rarely documented in detail. And another one is quantization, which reduces numerical precision of weights, example 32-bit to 8-bit floats, to cut memory and compute requirements. What impact it does on security? It can degrade safety aligned behavior. Backdoor defenses tested on fully precision models may fail to detect in quantized versions. So both steps are applied after the training is complete, often by a different third party team which is packaging the model to distribute it to the consumers. So it can silently degrade the safety mechanism built into the model. So next we have federated learning. So this model is trained across the model is trained across many decentralized devices or organizations, with each participant training locally on their own data and only sending weighted updates. Okay, so this was designed with privacy in mind. A hospital sharing patient records to train a model is a data protection problem. So if a hospital contribute a model update without ever sending the records is as a much easier conversation. So it federated learning generally does reduce privacy risk at the data level. So what's the security trade-off here? Is that integrity of the training process becomes much harder to verify. So when a setup is centralized, the organization trains the model, controls the data. But in a federated setup, all the participants are sending individually and pushing the data. So it's highly likely that a participant can submit a poisoned local updates, which can certainly manipulate the design of the model and integrity of that. Okay, so let's see what term describe one complete pass of the training algorithm through the entire data set. Epoch. What problem occurs when a model memorizes training data rather than the learning general patterns? Overfitting. So what post-training optimization techniques reduces the numerical precision? We saw numerical one was quantization. What training approach trains a model across decentralized devices? It was federated learning. Let's go to the inheritance problem. So training an LLM from scratch means assembling trillions of tokens of data, acquiring compute infrastructure, and run a training job that can cost tens of millions of dollars. Okay. So pre-trained models and fine tuning. A pre-trained model is one that has already been trained on a large general purpose data set. These are base models. They are produced by a small number of well-resourced organizations and then made available for others to build on, either through open weights or through API access. So like a base model is already there for you, which has been already trained on tons of data, and now you can like train it, it fine tune it using your own data by training it on your own data. Okay, so it is a process of continuing to train one of these pre-trained models on a smaller task-specific data set. So a healthcare company might fine-tune its base model trained on clinical documentation to improve its understanding of medical terminology. A law firm might fine-tune on case law. So what fine-tuning changes? The model's task-specific behavior, tone, and domain knowledge. What it does not change, the base model weights, the billions of parameters saved by pre-training, and which you never saw or has been certainly never audited. So this is where security concern sits. When you find in a pre-trained model, you inherit everything of that like base model. This includes things you cannot see and you did not choose, like biases baked in during pre-training process, unexpected behavior, any safety alignment. So there is safety alignments erodes, not breaks. So standards and defense mechanism of aligned LLMs can be compromised by fine tuning on as a few of 10 adversely crafted examples. Okay, then we have specialization increases attack surface. Cisco found that fine-tuned models are as measurably more susceptible to prompt injection than the base models they were fine-tuned on. The reason is structural. Fine-tuning narrows the focus, reducing resilience to unexpected tokens. Version matters and it's rarely tracked. Fine-tuning always targets a specific checkpoint of a base model. So if that checkpoint later turn out to be a backdoor problematic training data, then everything you have already inherited and trained your data on that. So you are impacted. What is inheritance tax? So when your org deploys a fine-tuned model, you are not deploying the fine-tuning work your team did. You are deploying the entire pre-trained base data, which was it on which it was trained. Okay. So what is the process of taking a pre-trained model and continuing to train it on a smaller task? We just saw that multiple times. It's fine-tuning. So what term describes a model that has already been trained on a large general purpose data set? So it's pre-trained model. Now what is the black box problem? Models are a black box. So when a security team wants to audit a piece of software, they have options. Source code is always there to read. Okay. Even compiled binaries can be disassembled, stepped through, and reasoned about. A trained model's weights are neither. They are billions of floating point numbers. You don't know from which sources and how, and you can never audit like hundreds and thousands of data sources, right? They carry no human readable record of how they were shaped, what data influenced them, are they biased. You cannot open a model and find a decision that make it behave a certain way. So this is a black box in a true sense. So there are some model cards. So let's see. The documentation artifact designed to address this is the model card. A structured document that accompanies a model and describe what it is, how it was built, where it falls short. It was just introduced by Google researchers. So the first section is training data. What it should tell you, what sources were used, how they were filtered, and known gaps or biases. What is the intended use, what the model was designed for, and explicitly what it isn't. Performance matrices, the conditions under which the model is known to underperform. when training data or evaluation may have introduced skew, and what we are legally permitted to do with the model. Now, what are the gaps? A sparse or missing model card isn't an inconvenience, it is a warning sign. Right? So, unlike food labels, there are no regulatory requirements to produce one. As of now, it remains voluntary for most use cases. So, let's see. The model card is your audit trail. In the absence of one, there is no audit trail, just a black box. So, what documentation artifact companies a model? So, it's model card. What are the billions of floating points number that make up a train model collectively referred to as? I think uh, weights. No. Okay, then it could be weights. I think. Yeah. Let's go to practical view site. Your job is to perform a model audit. Think of it as a scavenger hunt for red flags, the warning signs that a security conscious engineer should never ignore. Okay. After you submit your findings, you will get a feedback on each one, learning the severity and significance of each issue as you go. Let's see. You are a security analyst. Your team has been asked to evaluate whether this particular model is safe to integrate into internal tooling. Complete a security review of the model card and flag any concerns before sign off. Our task is to read through the model card, files, and sidebar details carefully. Hover over suspicious text to reveal hotspots. Click them to flag finding and rate their severity. Let's begin the audit. So it's the Hugging Face, which is very popular to hosting your like models. This is a simulation of Hugging Face. Okay, let's review model card. A text classification model designed for enterprise document routing and categorization, fine-tuned from enterprise base. Okay, so it is fine-tuned, so a lot of base data will come. This model classifies incoming documents into organization categories such as support tickets, procurement requests, compliance queries, and internal communication. Okay, let's go ahead. So use example training data. Model trained on data curated from publicly web sources. Okay, so you can see as we went here, it got highlighted, which means this is a security issue here. While auditing, it is trained on publicly available web sources. We saw in earlier in the task that it has a very low trust score, including forums and QA sites and public documentation. So what should be severity? It has a very low trust profile. No data is validated and fact checked. So we can mark it as high, I guess. Same I think we can do for this. Let's see. The training corpus was assembled to form a broad range, and this many samples were used across classification categories. Let's see training procedure. Fine-tuned from enterprise base v.1. Okay, this is getting highlighted, which means we have to assign severity for this. So it is fine-tuned from this base model, which means a lot of inheritance risk is there. So I think we can mark it as let's say medium. Using a standard cross entropy loss, training ran for 8 epochs with each learning rate of 2e5. And okay, let's say intended uses, document routing, then we have support triage, then we have compliance filtering, and at last we have internal communication. Okay, so nothing is highlighted here. So evaluation on a held out total set of 10,000 samples, and it achieved a macro average F1 score of 0.91 across all classification categories. Okay, so it's not 100%, so I think we can mark this as medium. Let's go ahead. License, custom license, contract, trust, DI lab for terms. Okay, so license is custom, but they are asking us to contact. So let's see. Stats downloads 127. It was created on March 24. Organizations not verified. 2 models. License is custom. Let's see files. README file is there. Configuration. Okay, so this is how available. It is 268 MB. Okay, I really don't know why it is getting highlighted here. Okay, let's see. Okay, so it's a pickle file. Let's see. I I really don't know what should be severity of this. Let's just mark low for now. Submit 6 by 6. Okay, you identified 5 by 6 flag. So we got the flag. Okay, but let's see what was correct and incorrect. Okay, so the public one was correct. It was of high severity. No mention of PII filtering script from formed in data in corpus. Fine tuned from enterprise base v1, a specific version with no documentation of what that version contains. Okay, medium severity. No bias evaluation, no limitation section, and a sparse evaluation section with no adversarial rating testing documented. Okay, license listed as custom with no link, no terms, no contact details beyond the organization name. Again, medium. So model file size is significantly smaller than the base model with no document of what posted in image. Okay, so it is acceptable, but the optimal rating is not low. Okay, so model size is smaller than the base model. So base, okay, so it should have been like larger than the base model, of course. So either you can like audit again, and if you have already got the flag, you can skip there, but you can definitely do this again and find the correct severity for that size. Okay, let's submit the flag. Okay, so we are done. Again, there is a conclusion. What you learned here: AI training data is from poorly documented on sources. Then about PIA and life credentials, model building, then model card. What is fine tuning a data? So that's all for this video. I will see you in another video with another room. Till then, keep learning.